In this video, we're going to look at non-direct variation tables. So we're going to use the table to figure out the equation, assume we have a constant rate. And we can actually verify that a constant rate as well. Table A, T is time in hours, D is distance in miles from home in miles. We see right away that when I look at time 0, my distance is 10. So that means this is not a direct variation. It is not proportional. Remember, in order to be a direct variation, it has to be linear through the origin 0, 0. Because here it does not go through 0, 0. So we're going to have to solve these using a different idea. Still linear though, so we can use those ideas, and that's what we're going to talk about in this video. Number 1, how far away from home were they when they started? Take a moment and try to figure that out. Otherwise, the start idea is your y-intercept idea. And your y-intercept is when your x is equal to 0. In this case, is x the t or is x the d? X is the t. We see that t is equal to 0, my distance is 10. Again, the x equal to 0, y equal to 10, or t is equal to 0, d is equal to 10 is your y-intercept. Now number 2, how fast were they driving? Before, with direct variation, I could just take the d and divide by t, and that would be my speed. How fast is my miles per hour? So 50 divided by 1 would be 50 miles divided by 1 hour, but that doesn't work because notice 90 divided by 2 is not 50. So because these aren't equal, I know this is not a direct variation because it's not proportional. Thus, I need a different way to figure out how many miles or I drive in 1 hour. Take a moment and see if you can figure that idea out. Otherwise, take a look at this. My how fast is my speed or velocity. We can figure that out by doing our miles divided by hours. But it has to be the change in my distance or my change in my time. The triangle means change in. So what I have to look at is pick 2 points. So let's pick the first two. I have a point at 0, 10 and 150. So we see starting at 10 miles, I went to 50 miles. So my question is, how many miles did I go? That would be 40 miles. I can figure it out by doing the difference between them. Next question is the change in t. So how many hours passed going from 0 hours to 1 hour? That would be 1, again, by taking the difference between them. So that gives me 40 miles over 1 hour, and that equals 40 miles per hour. So they're going 40 miles an hour. They started 10 miles away from home. For number 3, I want to write an equation where d, my distance in miles, is a function of t, time in hours. Take a moment, see if you can write that equation knowing my speed, which is slope. And technically it's a rate. Slope doesn't have any units, but we use them pretty interchangeably in math. And my y-intercept. Try to write the equation for number 3. Otherwise, here's that equation. D equals 40t plus 10. Whenever it says letter is a function of another letter, the first letter is like your output or dependent variable, or like your y idea, and part after is a function is your x idea. In this case, that was the t. My distance in total is figured out by having 40 miles every hour, right? So 40 times the number of hours I drive would tell me how many miles I've driven total. But I still have to add in that 10 miles that I started already away from home. So it's 40 times t plus 10 gives me my distance. Take a moment and try to do table B. Here I have time at 0 is 24, 1 is 56, at 2 hours is 88, 3 is 120, 4 is 152, 5 is 184, etc. Again, answer questions. 4 is how far away from home were they when they started. 5 is how fast are they driving. 6, I want to write the equation where D is distance in miles, and it's a function of T, time, and hours. See if we can answer those. Otherwise, here are those answers. My starting from home at time 0 is 24, so 24 miles is my answer for number 4. How far away from home were they when they started? How fast are they driving? Again, that's the idea of slope. How many miles did they go? So from 24 to 56 is 32 miles. And from 0 to 1 only means they went 1 hour to get there. Notice between the 56 and 88 is also 32 miles. And from 1 hour to 2 hours, again, that's only a difference of 1 hour. This is true no matter what you jump between. If I go from 1 to 3 hours, 1 hour to 3 hours, that would be a difference of 64 on my distance, but 2 hours to get there. Again, that's 32 miles then every 1 hour. So my slope is 32, my y-intercept is 24, my equation is D equals 32t plus 24. Use the same type of ideas on table C and table D. In table C and table D, you can verify you're correct with your equation by plugging in the time values on C and D and see if your answers are the same as the tables. Why don't you take a moment and try to do table C. Your time at 0 is 15 miles, time at 2 hours is 65, time at 4 hours is 115, 6 hours is 165, 8 hours is 215, 10 hours is 265. See if you can figure out how far away from home are they when they started, how fast are they driving, what would be my equation. Take a moment, try that problem. Otherwise, we see my start distance from home is 15 miles. How fast are they driving? Again, similar idea. How many miles did they drive? So we see 65 miles, how far they were. Starting 15, that's a difference of 50. But unlike number 1 and number 2, they didn't do that in 1 hour. It actually took them how long? It took them 2 hours. So they went 50 miles in 2 hours. That's how long it took. It means that actually we're only driving 25 miles an hour. Using my y-intercept and my slope, we can write my equation. D is a function of t. Again, makes D the y idea and t the x idea. So my equation is D equals my slope, which is 25, and my x idea, which is t here, and then my y-intercept, which is a positive 15, so plus 15. So my equation number 9 is D equals 25t plus 15. Again, I can verify this equation is correct by plugging in any of the x values from the table, 0, 2, 4, 6, 8, or 10, and I should get those distances that correspond to those times and hours. Now try table D. Time 0 is 30 miles, times 3 is 165 miles, 6 hours is 300 miles, and 9 hours is 435 miles. See if we can answer how far away did they start, how fast were they driving, and write our equation. Take a moment, try that. Otherwise, how far away from home were they when they started? How far tells me that I'm finding the distance. I'm going to do that when we start. Start is when time is 0. See that for the time equal to 0, my distance is 30 miles. Again, because my time is 0, I'm finding the y-intercept. Next question asks, how fast are they driving? So again, how fast means I'm finding a speed. Speed is rate. Rate is slope. So I need to figure out how many miles per hour did they drive. To figure that out, I need to figure out how many miles did they drive and figure out how many hours did it take to drive that many miles. So I'm using the point 0, 30 and 3, 165 to figure out my answer, but really you could use any of the 2 points. They don't have to be next to each other. You could use 0 and 30 and 9 and 435. Still going to come up with the same miles per hour. So my velocity is equal to my miles I drove. To figure that out, I'm doing 165 minus 30. Right, so I was at the 30 mile mark. I'm at the 165 mile mark after 3 hours. And we figure how many miles is that then that I drove. So I drove 135 miles, but again, it took them 3 hours. So 135 miles divided by 3 hours gave me 45 miles per hour. So we found that I was started 30 miles away. I drove at 45 miles per hour. If you haven't done so already, take a moment and try to write the equation where d is a function of t. Otherwise, use that equation. D equals 45t plus 30. Again, I'm driving 45 miles an hour for t hours. That's my distance I've traveled, but I have to add in that 30 miles that I started away from home for my total distance. So again, big ideas on this one is once I start moving past non-direct variation, I can't just take the y divided by the x. I have to figure out, well, how much did I go and how long did that take? So again, you're finding the difference between these 2 points and dividing that by the difference between the x values. Change in y divided by the change in x.